Myself, Dr. B.J.D. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about question bank questions of Module 3, that is CPU and the Computer Arithmetic. The first question is, explain the memory reference instructions. So, instructions may be placed in several different kinds of categories. So, the user can perform the intended task by writing the program. A program is a collection of instructions. Each instruction can specify what task to be performed by the user. So, here variety of instructions can be framed in the program. So, the conceptual applications are meaning are performance-based location of operation. So, based on the performance-based on location of operation, three types of instructions are there. One is register reference instruction. Second one is memory reference instruction. Third one is IO reference instruction. What are memory reference instructions? Once an instruction has been loaded to the instruction register, it may require further access to the memory to perform its intended function. Okay? To perform its intended function, the instruction register can be once loaded into the instruction register, so the further processing can require the memory access. So there are two methods of memory access can be possible. One is direct access. Access the storage at the specified instruction register address. The second method is indirect access. So here access the storage with the instruction register address can specify the effective address of the operand in case of indirect access. So here the instruction register can be used to represent the address. Next, the opcode. And last bit, the 15th bit of instruction register can be used to represent the mode of access, that is based on the I value. If I value is equal to 0, it is direct access. If I value is equal to 1, then it is indirect access. So, what is direct access means? Whatever address that is specified in the instruction register, for example, 300, in the memory, at the 300 location, the operand can be available in case of direct access method. So that this operand can be fetched and used for the processing. In case of indirect access, if the 300 location is specified, at that memory location 300, another location can be specified. Another location of the memory can be specified. So, if it all, this is the 450 location of the memory, at this location, the operand can be available. So, in the indirect access, the address that is specified at the instruction can be used to retrieve the effective address of the operand. So, 2 cycles can be required to fetch the actual operand from the memory in case of indirect access. So, that is the difference between direct access and indirect access. The list of memory referenced instructions are AND. The mnemonic AND can be used. So, AND memory word to the accumulator. So, the logical operation AND can be applied. The word that is fetched from the memory and the accumulator. The second operation is add. Add memory word to the accumulator. Next, LDA, load memory word to the accumulator. STA, store content of accumulator in the memory. So these two can be used to perform the read and write operations from the memory. Next, BUN means branch unconditionally. During branch operation execution, the execution sequence of the program can be altered without checking the condition. So that is called the branch unconditionally. BSA, branch and save return address. So the sequence of the execution can has to be traversed to the specific label, as well as the return address can be, the PC address can be saved in case of BSA. Next, ISZ, increment and skip if 0. So the status register flag bits Z is used to test the 0 value. If the 0 bit is on, then increment. So this is called ISZ mnemonic. Now we'll discuss these memory referenced instructions with the corresponding register transfer language symbols. So the first operation is AND. AND is used to perform the logical AND operation between the memory word and as the accumulator. So what is the address that is pointed by the memory, and between that word can be assigned to the data register, and between accumulator and the data register, the AND logical operation can be performed. And the next one is add. So the memory address can be transmitted to data register, and the addition operation can be performed between accumulator and the data register. Next one is LDA. So here the data register can be assigned with the memory word that is pointed with the help of address register, and the data register value can be assigned to the accumulator. Next, STA. So here accumulator value can be assigned to the data register, and data register value can be moved to the memory pointed by the address register. Next, BUN, branch unconditionally. So here the address instruction register 0 to 11 can be part of the instruction register bits, can has to be moved to the address register. The address specified in the instruction can be moved and pointed by the address register, that can be moved to the PC. Next, BSA. In this 0 to 11 bits, the address bits of the instruction can be moved to the address register, and PC value can be moved to the memory location that is pointed by the address register, and PC value can be assigned with address register incremented by 1. Next, ISZ. So here the address register can point the address that is specified in the instruction. Data register can be moved with the data that is pointed at the address register of the memory, and this data register value is assigned to the accumulator. Accumulator value can be incremented, and this incremented value can be moved to the data register, and data register value can be moved to the memory location pointed by AR, and testing the AC value. If accumulator value is 0, then only the PC value can be incremented. So these are the variety of direct address memory referenced instructions that can be notated by using the RTL. What are indirect address instructions? And so here the address register can store the address specified by the instruction register, and data register can contain the memory value that is pointed by the address register, and data register 0 to 11 address can be moved to the AR register, and here between these the accumulator and the data register the AND operation can be performed. So here 2 cycles can retrieve to fetch the operand. With this operand the accumulator value can perform the AND logical operation. To perform add also 2 cycles can be required and in order to perform the addition operation. Transfer instructions can be used in the memory reference instruction. They are loading and storing, LDA and STA instructions. So in case of LDA, the accumulator has to move with the data register value, which in turn contains the memory location that is pointed by AR. Those value has to be moved to the accumulator. In case of STA, the store operation, so writing of the data. So here accumulator value first assigned to the data register, and this data register value can be moved or transferred to the memory that is pointed by the address register. So LDA and STA are the transfer instructions. They can be used to transfer to and from the memory the data. Addition and AND instructions. So the logical AND is done on all bits of the register in parallel. So numeric or 2's complement addition may be done in serial or in parallel using look ahead circuit. How this AND operation can be performed. So here the data register can be loaded with the data that is fetched from the memory at the address register. Between the accumulator and the data register, the AND logical operation can be performed. So here first the data register contains the data that has to be fetched from the memory with the help of address register that is pointed. And this address register value with the accumulator, the AND and add logic can be applied. In case of add, the plus or addition operation can be performed. What is branching? So, during instruction that explicitly modify the PC during execution. So, the program sequence can be altered with the help of branching instructions. This implies that next instruction to be executed is not located in the next continuous word of storage. So generally with the if then else, the control structures in the programming languages, how you are used in the high level programming language, in the assembly language, the branching can be used. So branch unconditionally can be done with a mnemonic BUN. Branch and save can be used to store the return address. So it is specifically helpful during the subroutine calls. So increment and skip if 0. So use it to implement a counter based construct just like do while loop, how you are using in the programming languages. Next question is make use of program interrupt. Build the flowchart for interrupt cycle. So first we have to discuss about what is an interrupt. An interrupt is a signal that requires the processor to suspend the current task that is being executed by the processor and traverse to the interrupt service routine. After completion of execution of interrupt service routine, the CPU can resume the main program execution. So to service the interrupt, the processor executes the corresponding interrupt service routine. After execution of the interrupt service routine, the processor resumes the execution of suspended program. So how the interrupts can be executed? So this is the user program. The CPU generally executes the program in a sequence one instruction after another instruction. When there is an interrupt rises, that is the signal that it can be received by the CPU. It has to stop the current instruction execution and can traverse the control to the interrupt handler to the interrupt service routine, and that service can be provided by executing the program at the ISR, and after completion of interrupt service routine, it has to return to the next instruction and can resume the execution of the user program. In this way, the interrupts can be executed. So what are the types of instructions? Are majorly two types. One is hardware interrupt, second one is software interrupt. Hardware interrupts are two types: maskable interrupt, non-maskable interrupt. So hardware interrupt can be raised with the help of hardware components like flip-flop registers can be used. So if your processor resolves the interrupt request from an external I/O device, it is termed as a hardware interrupt. So hardware interrupts can be further divided into maskable interrupt and non-maskable interrupt. What is maskable interrupt means? Whenever this interrupt can be received by the CPU can ignore this maskable interrupt and can execute the current task. Those can be the maskable interrupt. In case of non-maskable interrupt, the CPU should not ignore them. They has to forcibly execute the interrupt, and they has to be serviced first, and higher priority can be given to the interrupt. Then those interrupts can be called as non-maskable interrupt. They cannot be avoided or ignored or delayed by the CPU. So those category can be treated as non-maskable interrupt. And the second method of type of interrupt is software interrupt. With the help of software instruction or with programs, the interrupt can be occurred. Those interrupt can be treated as software interrupt. Like by using system calls, by using exceptions, the software interrupts can be raised. So these are the types of interrupts. What is the interrupt cycle? A program or instruction can be executed by using the instruction cycle steps. So after completion of instruction cycle, the CPU checks whether any interrupt is enabled or not. If it all enabled, it has to move to that and service to that interrupt with the help of interrupt service routine. So here start and fetch the next instruction, execute the instruction until thus the instruction cycle. Next, it can check for interrupt enable. If it all interrupt is enabled, and service that interrupt and return to the execution of the main program. If it all interrupt is disabled, go and fetch the next instruction and continue the execution. So at the end of completion of each instruction cycle, the check for interrupt can be done. If it all it is enabled, interrupt service routine can be executed. Now, and the I/O instructions with the interrupt initiated I/O, the I/O instructions can raise the interrupt. So during input, INPR register associated with a flag FGI to indicate the input interrupt can be enabled or disabled. The buffer status can be indicated. And during output, by using outer register and FGO, the indicating the buffer status and the status of the interrupt. So here during the input, For example, take the keyboard, transmitter interface with the INPR, the data, and FGA can show the status. Similarly, the output, and with the help of FGO, the printer or the output devices can done the output process. What is the execution of the interrupt cycle? How it can be performed? So this is the flowchart for the interrupt cycle. So R is the flip-flop. By using this, the CPU can detect whether interrupt is enabled or not. If it all R value is equal to 1, then interrupt is enabled. It can start executing the interrupt cycle. If R is equal to 0, then move on to the instruction cycle. So depending upon the R flip-flop, the interrupt can be detected and can be serviced. If R value 1, interrupt cycle can start execution. So storing the return address and branching to the interrupt service routine and executing the interrupt service routine. And here in case of instruction cycle, fetch and decode the instruction. If that instruction is pertaining to the input-output instruction, then the IEN can be enabled. If that IEN enabled, that input-output interrupt can be interrupt-initiated IO can be taken place, which can be either input or output, that can be decided with the help of FGI and FGO. So after that, the execution of the instruction can be performed. So in this way, the interrupt cycle can be executed and interrupt can be serviced. So the state diagram of interrupt cycle is instruction address calculation and fetch the instruction at that location, instruction decoding, operand address calculation, operand fetching, data operation, operand address calculation, operand store. So until this, the instruction cycle is completed. Interrupt check. If it all interrupt, then go for the execution of interrupt cycle. So in case of multiple interrupts can be occurred, then there are two approaches to handle this state. The first is to disable interrupt while an interrupt is being processed. A disabled interrupt simply means that the processor will ignore the interrupt request signal. So those are maskable interrupts. A second approach is define priorities for the interrupt and allow an interrupt of higher priority to cause lower priority interrupt have to be wait. So these are the two approaches that can be used when multiple interrupt can be raised at a time. Next question is, what is mean by program control? Discuss. So here another variety of instructions are available. Data manipulation instructions, data transfer instructions, program control instructions. So here computer provide excessive set of instructions. So in these three varieties of instructions are available. Data transfer instructions are used to transfer the content of the registers or from registers to memory. The content can be transferred but without changing the content. Generally, the examples are MOV, move. Those instructions can be come under the category of data transfer instructions. Data manipulation instructions can provide arithmetic as well as logical processing capacity. And all these instructions are the examples of data manipulation instructions. The third category is program control instructions. The program control instructions are generally used to alter the sequence of execution of the program. So program control instructions specify the conditions for altering the content of the PC so that the PC address can be changed and the control can be moved to the specified location, can alter the sequence of execution of the program. While data transfer and manipulation instructions specify conditions for data processing operations. The change in the value of PC as a result of execution of program control instruction causes a break in the sequence of the instruction execution. So these instructions provide control over the flow of program execution and capability of branching to different program segments. And the list of program control instructions are branch with a mnemonic BR, jump with a mnemonic JMP, skip next instruction SKP, call procedure CALL call, return from procedure RET, compare CMP, test TEST. These are the list of program control instructions. The first instruction is branch. Branch is one address instruction. When executed, the branch instruction causes a transfer of value of address into the PC so that the program's execution can be altered. The second one is jump. Branch and jump instructions are used interchangeably so that the program execution can be altered. Skip. Skip instruction will move to the next instruction. Call is used to invoke the subroutines. Return is written from the subroutines. Compare performs two operands, but the result of the operation is not returned. However, certain status bit conditions are set as a result of the operation. Test performs logical AND of two operands and updates certain stated bits without returning any result. So these are the list of program control instructions. What are the status register bits? 4 bits are generally used. They are C for carry, S for sign, Z for 0, V for overflow. These bits can be stored in the PSW register and can be set according to the different data manipulation, processing and program control instructions. So this is the program status word and these are the status flag flip-flops. If carry bit is C, the carry bit can be the C8 equal to 1 if it all set to 1, otherwise it can be 0. S means sign, F7 is equal to 1 or it can be 0. Z means it has to return all zeros. V means overflow. So exclusive OR of last two carries has to be equal to 1. How these program control instructions can be used in the assembly language program. Branch, the memory address location can be used. JMP, again is a label. SKP, skip to next instruction. Call the specific function. FUN1, return from the procedure or subroutine. Compare, test. So what are the conditional branching? Before branching, the condition can be tested. So depending upon this status bit, Z, C, S, V, these conditional branching can be taken place. BZ means branch if 0, Z flip-flop can be used. BNZ, branch if not 0. BC means branch if carry. BNC means branch if no carry. BP, branch if plus. BM, branch if minus. Branch overflow BV, branch if no overflow BNV. So based on the 4 status flip-flops, the conditions can be tested. So similar way here, based on the comparison of the two values, the condition can be tested and branch operation can be take place. BHI branch if higher, depending upon A is greater than B. BHE branch if higher or equal, A is greater than or equal to B. BLO branch if lower, A is less than B. BLOE branch if lower or equal, A is less than or equal to B. BE branch if equal, A is equal to B. BNE branch if not equal, A is not equal to B. So depending upon the comparison of the two resistors after producing the A minus B, the comparison, the branching can be taken place. So depending upon the same comparison, the signed branching can be taken place with the help of next set of instruction. BZT branch if greater than, next BZE branch if greater than or equal to, BLT branch if less than, BLE branch if less than or equal, BE branch if equal, BNE branch if not equal. So all these are the conditional branching statement. So how they can be used in the program? INC incrementing the EDX value, comparing EDX with the 10 value, jumping JLE LP1. So if it is less than or equal to 10 value, the jump to LP1 label can be taken place. So in this way, the program control instructions can be used to alter the execution of the sequence of the program conditionally or unconditionally. Next question. What are the two cases for subtraction method for 2's complement? So in the 2's complement subtraction, the process is the first step. Find 2's complement of the B, that is the subtrahend. Then add it to the U, A, the minuend. So after addition, if in the sum they are producing an extra bit, then the result is positive. If there is no carryover, the 2's complement of the sum is final result is negative. So the sum has to be 2's complemented. So this is the procedure for subtraction with the help of 2's complement. So now the two cases are, the first case 1, addition of two positive numbers with a negative number when the positive number has a greater magnitude. So initially find the 2's complement of given negative number. Sum up with the given positive number. If we get end around carry 1, then the number will be positive number. And then carry bit will be just discarded. Remaining bits are considered. So this is the case 1. So how this can be implemented with an example we can perform. So A value is 110. B value is 101. So the subtrahend has to be finded the 2's complement of B. So the B value is 101. First we have to find the 1's complement of B by interchanging the 0 as 1, 1 as 0. So 0, 1, 0 is the 1's complement of B. Now 2's complement can be done by adding a 1 to the 1's complement. So 0, 1, 1 is the 2's complement of B. How the 2's complement subtraction can be performed? The A can be specified like this, and B value, 2's complement of B value can be added. So 0 plus 1, 1, 1 plus 1, 0 with a carry 1, 1 plus 1, 0 with a carry 1. If at all an extra carry is produced, that can be discarded. So this is a positive number. The result is a positive number. So result is 0, 0, 1. What is the second case of 2's complement subtraction? adding the positive value with a negative value when the negative number has a higher magnitude. So initially adding a positive value with the 2's complement value of the negative number. Here no end around carry is to be found. So we have to take 2's complement of the result to get the final result. So consider the example. A value is 10110, B value is 11101. So 2's complement of B can be found. So first we have to find the 1's complement. It can be 0010 and 2's complement can get by adding a 1 to 8. So 0011 is the 2's complement of B. Now A can be 10110 and for this the 2's complement of B can be added. So we have to perform the addition. So 0 1, 1 plus 1 0 with a carry 1, 1 plus 1 0 with a carry 1, 1 1. Here no extra carry can be produced. No extra carry. So it is a negative number. So in order to find the result, this sum can be 2's complemented. So the 1's complement of this is 00110. Now by adding a 1, 00111. So this is the final result. So these are the two cases of the 2's complement subtraction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.